Welcome to this week's video. We've just about finished the lower wings, all bar varnishing them. So let's see what we got up to. Right, I've got to create this bend in the control tubes, which I've put one of the end pieces in, as you saw last week. I'll get that bend sorted out and then we'll cut the tube to length. So to get that angle, which works on the wing, I'm just going to use this this gauge, this bevel gauge. So now I've got that angle. I don't need to know what it is. It's for the aircraft, so it might be different on other people's. So I've got that. All I'm going to do now is we'll put a mark on here, 2 inches from the end. That I will line up with the edge here on that 0. Okay, so I've got the bevel gauge. I've got this set up with the pipe in position. I've just twisted this so that the rivet's not sitting against there, because that might cause a little bit of aggravation. And now I'm going to try and bend this to a matching angle. That looks about perfect. What I'm going to do now, just to keep myself right for the next one, is I'm just going to draw a line straight across there. Now I know when if I need to bend it a bit more, I know I have to go past that. And also this should help me set up for the next one, so let's have a little look. So I've just got 2 holes in the bench with the 3/16 holes in, which I've set at the distance which we had on our trial piece, and the rods which I've now got both ends fitted, and I've just given its initial coat of prime. I've got these now set up. So they just slide straight on there, so same length for the pair. So we're pretty close at 25.1 degrees. So again, over here onto the bar, and we'll draw that line. Now what I'll do is I'll measure the distance between those 2 lines and put another line here somewhere, wherever it is, and that way I can then move the aileron across to that line and we'll know what we've got down. So now with it set the other way, an equal amount, 25mm of travel either side of the centre position is what I've got on the control rod going into the bell crank. So with that I am getting 18.7 degrees or thereabouts. Yeah, 18.7, 18.8, it's sort of flickering around a little bit. 18.8 I'd say. Degrees of down. So to get that I had to just extend the rod slightly at that end a little bit. It's the longer the rod is, the less differential we get. The shorter the rod is, the more differential we get. One thing I've got to point out is that the rod, control rod, would have to slope, so we're going to have to cut out a little bit on the geodetic on the front ribs to make sure that's running parallel. I'll do that once I've got the wings fitted to make sure I get it exactly right. Also, this is 3/4 inch wide and the tube is only 1/2 inch, so might be a little bit of extra space there, but I don't want it actually rubbing and binding on the surface here. So yeah, asking a question on the Fisher site on Facebook. I got an answer from somebody who's built the Youngster before, and they said that they had to dress the front ribs slightly. So there's my template for the covering support, which gives us a good clearance around the tube. We will have a little fairing coming up and over here. Well, there's the support in place, nice and free movement. Actually, I sort of second thought about what I could actually do as a cover over here rather than having a bit of plastic. If we go traditional, I've got this this leather, and you have that. It's quite firm, and should it get, it's not going to restrict the movement at all, so can't see it getting caught. So that would make quite a nice little weather fairing to go forward. That could just be bonded into place with some contact adhesive on top of the covering. Okay, we've been talking about aileron differential. What is aileron differential? Well, let's see first off what happens with a normal aircraft in flight. If you want to roll the aircraft to the right, we have one aileron goes up, the other aileron goes down, about the same amount, and the aircraft would bank, you'd think. But what happens is we've got two types of drag. We've got induced drag, which is caused by lift, and we've got form drag, which is caused by the shape of the aircraft. So the upgoing aileron and the downgoing aileron increase the form drag, but the induced drag increases with lift. So the one that's going up is reducing the lift, so it reduces the induced drag. The one going down is increasing the lift, so it's increasing the induced drag. So what happens is we end up with more drag on the outside. So as we do the bank, it drags back and we get what's called adverse yaw. So one method of getting around that on some of the complex aircraft is on the underside of the aileron they have a section which pops out under the skin of the main plane, creating extra form drag on the upgoing aileron to help balance it out. But on simple ailerons like I've got on this model and on the Fisher, the way we get around it is we do what we call differential aileron. So the aileron that goes up more than the aileron going down. Well, that does reduce the roll authority slightly. So generally what we do is we increase the amount of up to the amount of down, equaling it out, and that way we're not increasing induced drag as much on the outboard wing, and we're increasing the form drag more as well as reducing the lift. So hopefully it keeps the aircraft balanced in roll, so we don't get so much secondary effect. That said, having adverse yaw is a benefit to us when it comes to flying tail dragger aircraft. A lot of people talk about the most important control being the rudder on a tail dragger. Well, the aileron is as important in a lot of cases. When we come down to land, if we've got a crosswind from one side, we don't crab in, because if we have any side load on our undercarriage, we're liable to ground loop. So what we tend to do is we tend to come in with a wing low, forward slip. So we're having to put rudder in to counteract that turn effect that we'd have with the roll. So in this case, right aileron, left rudder. Well, if we've got adverse yaw happening, the downgoing aileron is creating drag, which is effectively reducing the amount of left rudder we need, helping us to do that forward slip. And when we're on the ground and the aircraft tends to want to weathercock because of the crosswind there, by having the aileron into wind right over, we are increasing that drag on the downwind wing, helping to stop and counteract that weathercock effect. So hopefully that explains a little bit about aileron dihedral, adverse yaw, the benefits, and one method of getting around it. So hopefully you can see, I'll just take one of the nuts off. That'll go through. I will have one of these nuts will be secured on with stud lock, but that's going through there. That's a nice firm fixing. Put the second one through. Something like that, and then we've got the strut tube going vertically here. These can feed in one in front to the other, up the front edge of the strut. So, but this nice and firm, it's not going to go anywhere. So I'm happy with that. Nice if we had them. Well, that's it for this week. We've got lots of bits finished off really. Piece of static system, aileron control rods made to length now, the aileron control rod outlet sorted out, the aileron range of movement sorted, the ailerons varnished or finished off on their varnishing, so they're ready now to be just have the sanding on the area where the covering is going to go and covered, which isn't going to happen for quite some time. So the lower wings now are effectively complete. Yes! Bar the main wings themselves being varnished. But that is something for some stage in the future. So let's see what I get up to next week then. Catch you later. Look after yourselves. Thank you for watching. If you enjoyed the video, please hit the thumbs up. You can subscribe or even hit the little bell notification for future videos. Any comments would be appreciated and I'll try to get back to you as soon as I can. Remember, go fly and feel the sky.